So the next thing in a solar system has got to be the battery. Now the battery, I would argue, is one of the most controversial things in solar systems, with people being, well, almost evangelical about their choice in battery. But it basically splits down to one of three choices. There's lead, there's lithium, what I'm going to call exotic type of batteries. Now, lead batteries also split down into different types. The cheapest and simplest is going to be the flooded lead acid battery, or the FLA. It's the old kind of lead acid battery with nothing done to it but a load of acid chucked in there. They're not very powerful. They don't store a lot of energy. The energy density of them isn't particularly good, and they don't last a very long time. On the plus side of it, they're really very cheap. They're probably one of the cheapest options. Now I'm going to go with that, and I'm going to go with that because I have 4 of these sitting in my garage doing nothing. That's the only reason that I'm going to go with it, because there are lots of other choices. There's something called gelled lead acid batteries, and then there's absorbent glass batteries, and there's batteries in combination with carbon plates, and they gradually get better and better in terms of their longevity and in terms of their energy density that they can store, but they remain the cheapest option. There is one issue with flooded lead acid, and it is that it's basically electrolysis, and it's electrolysis of a water solution, so it splits the water. And it will split a little bit of water into hydrogen and oxygen. And of course, if you have massive amounts of them, that hydrogen can be a bit of a problem. The FLAs also have a little hole in the battery to let that hydrogen out. Later on, they came up with the anodes and cathodes that would recombine the hydrogen, and so you got sealed lead acids where that wasn't a problem because the hydrogen was recombined. But if you use this basic type, they are giving off a little bit of hydrogen, and if you don't remove this little plug in the hole, you will blow the battery out like a football. And if you have a lot of them, you need to make sure that the space is ventilated. With 1 or 2, it probably doesn't matter much, but with loads of them, you're going to get a build-up of hydrogen. In the early days of lead acid storage, they made sure that it was ventilated. Now I'm going to put these in an outside cupboard because there's 4 of them, and I want to make sure that that isn't going to happen. So they're going to go into an outside cupboard. But like I say, later batteries that are sealed don't have that problem because there's a recombination in the battery itself. AGM is well known for its longevity, but even so, we're only talking about a few hundred charge and discharge cycles when it comes to something lead acid. The biggest bonus is they're absolutely everywhere and they're dirt cheap, and you can buy something called deep cycle batteries where they can go up and down and last for absolutely ages. So they've got their quirks about them, they've got varieties about them, and if it's a choice you want to make like me because they're there, then nothing wrong with that, go right for it. You'll just have to recognise that there are also limitations that you have to pay attention to. But that's true of every type of battery. Every type of battery has limitations that you have to pay attention to. The current best battery, I absolutely hate that word, but it's the current battery that is in favour is of course lithium ion, and lithium has itself a whole bunch of flavours. There's one called lithium titanium dioxide where the charge cycle, it runs into the tens of thousands. It will last tens of thousands of charges and discharges. But again, the energy density is less than other forms of lithium and the overall voltage is lower than other forms of lithium, but it does come with the added advantage of lasting a very long time. Other kinds, the popular kind, lithium iron phosphate, again, it has discharge and charge cycles in the region of hundreds of cycles instead of tens of thousands of cycles. It's a bit more expensive, it's more energy dense, but it is an alternative. And of course, there are other forms of lithium that get gradually better and better in their energy density, the amount of energy they can store, but they also go in price. And of course, they have a nasty habit, as people have seen, of bursting into flames that you can't put out. So there's a whole range of batteries available with various pluses and minuses about them, and at the end of the day, you're going to make a choice, and the choice really is going to be what you want and what suits your budget, what you have lying around, and what you want to do with your system. You can explore different kinds of batteries and weigh up their pros and cons for you, for your application. For me, there's never a best, there's one that will actually suit you. Now, another reason I'm going for these is because I want the adaptability of the system. I want to be able to change the system over time as I learn, because all that you do and everything you do is always a learning process. So I've gone for a system that I can adapt and change relatively easily without too much interference from one part and another, as I change my ideas, as I learn different things, as I experiment with different things. Because I did talk about the exotic kind of battery. An exotic battery can range from something that you can buy, like for instance nickel iron, which I know a lot of people actually like, and there's still factories that make these. I believe there are 2 in China still making nickel iron batteries. They're a very old battery and they supposedly have much longer life cycles. They're supposed to be much cheaper. But nickel iron is an interesting, already made exotic battery that you may want to turn to. And of course, for people who followed the channels for years, you know that I'm a battery chemist. So I'm interested in batteries that can be made at home. For instance, the zinc bromide gravity battery. Those kind of batteries I'd like to experiment with and see how it would fit in my small solar system. There are equally other things that I'm kind of keen about, and that is putting batteries and supercapacitors together, and how would that affect the charge, discharge and life cycle? Because research has shown that simple lead acid, its life can be extended unbelievably by the addition of a supercapacitor bank to act like a kind of sponge between the battery load and the battery supply. It's again something I want to be looking at. So adaptability is a big point in my system, and it might not be the point in your system. You're going to make those choices as you look at the various alternatives that are available to you and choose the one that's best for you. But all that aside, the batteries all connect up in the same way. And again, you have a choice, and again, you can bet your bottom dollar people will tell you that one way is better than another, and swear by it and give you hundreds of reasons, because thou shalt have only one battery and no other battery will go before me. And they'll tell you all of this stuff, but you're the one that needs to find it out and make your choice. But you can either connect them in parallel or series. Series is dead simple. It's just where you connect the plus and the minus together, and as you connect them together, the voltage goes up, but the amps remains the same. And you see that in lots of applications like your radio, where you're just chucking a load of D cells in line with the bottom touching the top. That's in series. In parallel is where all the pluses are connected to one bar, the bus bar, and all the negatives are connected to another bar, a bus bar, and then the voltage remains the same, but the amps go up. So it just depends again what you want to do. I've chosen a 12-volt system for reasons I've explained, so I'm going to connect my batteries up in parallel to maintain 12 volts, but increase the amount of amps that I can store. Now that brings with it some kinds of problems, because DC voltage does suffer from something called voltage drop. If you run a cable 10 meters, the voltage at the beginning will be about a half a volt difference at the end. The voltage drops because of the resistance in the cable. When you're putting in a DC system, you have to pay attention to voltage drop. So my system is from my shed roof to inside of my shed. It's about 2 meters, so it's not an issue for me. If you're running at 100 meters, you might want to think again about something like 12 volts. You might want 2448, or you might even want more. One of the big advantages of things like 12 volts, of course, is it's a readily available market. One of the big advantages of keeping something below 48 volts is you don't need an electrician's certificate, because it's the low voltage regulations that kick in to anything below 50 volts. So again, things you need to consider when putting your batteries together. But the practical aspects of putting batteries together, that is sticking them outside or in a protected container in case of fire, linking them up in parallel or series, are always going to be the same. So once we've decided on our batteries, the mechanics of doing it are pretty much the same. So of course, if you're going to connect some batteries, you need some wire. And the question is, what kind of wire do you need? Because this is a 40 amp hour battery with 330 amps that it can deliver. So what am I going to attach it with? Well, this thing, it's not a demon. It won't reach out and grab you and deliver all its amps that it possibly can. It's going to deliver the amps that you need of it. And that's a key point here. It's what you actually draw, and that's dictated by the circuit that you attach to it. So in here we've got these lights around 12 watts. I'm planning on putting a 60 watt machine in there, so we're talking about 72 watts, maybe some more lights, say about another 8 watts, 80 watts, so we've got about 80 watts in total. Let's add a bit onto that and call it 120 watts. So I'm expecting to draw about 120 watts at 12 volts, which means that's going to be about 10 amps. So my draw is going to be about 10 amps. Now on the input side of course, I've got two solar panels, 120 watts each. They're delivering at 12 volts, more or less. So we've got about 24 amps coming in and about 12 amps going out, more or less. That's going to be the kind of maximum sort of figures. That means we need something that's going to be able to cope with a 20 amp load. Now, if we want to ensure that 20 amp load, of course, we put a fuse in there of 20 amps, but the wire has to be able to cope with it. And that turns out to be about 4mm CSA, cross-sectional area. As long as the wire is a minimum of around that, we've got a huge safety margin and we're not going to burn our wire. And even if it is, we stick a fuse in there to protect absolutely everything. Now, I've got these lying around. These are jumper cables, and the reason I'm using them is because they're lying around. And actually they've got a 10mm cross-sectional area, 10mm squared cross-sectional area. And that's absolutely huge. You're talking about a cable that can handle 80 or 100 amps or something like that, and I want about 10 or 20 out of it. So yes, it's completely overkill, but as it happens, I had this lying around, so that's what I'm going to use because it's not costing me any extra. It's been in my garage for ages and I got about 6 meters of it. Brilliant. Of course, I can't just stick this on here. What I need to do is get some connectors, and what I need is some appropriate lugs on there, because with electrics, it's like anything. You take your time with it and do it patiently, you'll do a good job and it'll be perfectly safe. If you try to put a Jubilee clip around there and stuff that in and tighten it up, it'll work, but there's a question about how secure that's going to be and how long that's going to work. So, we grab some lugs, we grab some wire of the appropriate size. These are actually standard sizes. This is an SC35-6, 8, sorry. That tells me the hole size there and the size of wire that will go in there. So I trim off my wire, pop it into there, and then I've got a lug clamp, and I just squeeze it in that clamp. And when we've done that, we clean it up with maybe some heat shrink or some electrician's tape to tidy up these sides here so that it's nice and protected and looks pretty, and we've got no stray cables and nothing that can possibly touch. That's all the cables we need. So now we've terminated our cables, we need to attach them to here, and for that I've got these battery connectors. These particular ones I thought were kind of cute. They've got a couple of bolts at 6 and one at 8, so we can connect to there and use that as the lead out. We can connect to there to use that to connect either serial or parallel. Obviously there's one red and one green, or black. The red goes on there, that goes on there, and they're only the right size. This is 19mm, this is 17mm on this particular battery, just to check the size of your terminals. And we tighten those up and do that to all 4 batteries. Okay, so here they are set up in the battery box, and so we've got the negative running to the negative, and running from the negative straight the way through, and that will go to the charge controller. And again, positive to the positive, and you'll notice I've left the positive off for the moment, but that positive will then connect there and go to the charge controller, and that's what we mean by being in parallel. And of course the bottom is exactly the same because it goes to its own charge controller. Now we drilled a load of holes in here. There's one in there, there's one in there. Those holes need filling with silicone. Not so much to keep the weather out, it will help keep the weather out, but when you've got a moving structure or a steel structure, you need some buffer in there to stop the structure sawing through the cables, and putting a whole load of silicone around that will do exactly that job. And there's my battery cables fixed to the wall and passing into the shed. Now these aren't rated for exterior use, so I've just put them to the wall for the moment. What it really needs doing is a bit of containment, or a box putting over that to protect it, because of course I'm hanging spades here, so we don't want that to get damaged. That's so you can see it. Containment needs to go around it. So there's my battery cables coming through the wall, and there are my solar panels coming through the wall. So obviously what I need to do now is put the electronics in. So when I say the electronics, of course, what I mean really is the charge controller. But to be honest, there's going to be more to it than that. I mean, one thing, I'm using redundant systems and I want to be able to experiment with it. So we're looking at things like the charge controller. We're definitely going to put an inverter in. We've got buck boost control that we need to be looking at. We've got our fuse board that we need. We need a bus bar so that we can separate things out when it comes time to do my experiments. And so our next bit is the electronics board, and we'll get on with that. Once we've done that, we've done. Anyway, I hope you enjoyed the video so far. Thank you very much for watching, and please do remember to like and subscribe.